Have you ever taken pictures under artificial light, such as fluorescent lights, or maybe halogen lights in a hockey rink? And when you got them back and looked at them, they had weird colors and weird exposures. Well, in this video, we'll look at why and how to deal with it. Hi, Peter Charles here, Hooked for Life Photography. And today we're going to talk about artificial lighting problems. And I got this idea of doing this video when I was doing some photos of some Lego men for a depth of field video. And I have a studio down in my basement, and I was using it. I have LED lights, which is fine. I also have fluorescent lights in the basement. Well, I forgot to turn the fluorescent lights off, and I got some strange results as a consequence. So I thought, you know what, that's a good subject for a video on what happens to us when we shoot under artificial lighting, and we're shooting under certain conditions, and we get some awful looking results. So what I'm going to do here is I'm going to very quickly run through 30 photos I took in rapid succession of my little Lego men, and these were taken at 1/500th of a second under fluorescent lights only. All right, so my LEDs were off, we're just using the fluorescents. So let's take a look at what actually happened here. You notice how the color shifts, the exposure shifts. Nothing was consistent. Okay, now we're going to explain why. And the reason is our eyes see fluorescent lights or other artificial lights as a constant that is, going without any problem whatsoever. We see it as one solid light source like the sun, except it isn't. So here's what's going on in reality. Now, every red dot that you see along that line represents zero current, which means zero light. Each peak in that sine wave is maximum brightness of the light. And what happens with alternating current that we have in our houses? It's going in two directions, so it goes in one then the other. So it's constantly doing this. Or you can think of it as plus minus, either way you want to work. It's reversing polarity. And it goes according to 60 hertz, or which is 60 cycles per second, which means it's reversing 120 times per second. So 120 times per second, the current in your line drops to zero, which means you have no light at that point. So let's see what happens when we apply a shutter to alternating current and your light flickering like mad 120 times a second, which your eye cannot see. You cannot pick that flutter up. About 24 frames a second is reputed to be about the fastest the human eye can detect flutter or flicker. So let's see what happens here. We are going to look at this. Okay, here's the 60th of a second. That red box represents our shutter opening and closing for 60th of a second. And you notice it's caught two peaks. And no matter where we open up our shutter, it's always going to catch two peaks. And those peaks are maximum brightness. So if you're shooting at a 1/60th of a second, you're guaranteed to get maximum brightness in your shot. And remember, you're metered for this, so this is the correct exposure. So as you see, no matter where you are on that, you've got two peaks. So here we are at 1/125th of a second. Let's see if we catch any peaks or not, because if we catch a peak, we've got maximum brightness. We don't have to worry. Our photo will be properly exposed. So everywhere we look, it catches a peak. No matter where you are on there, you're catching a peak. So what that means is you can take a photo at a 60th of a second or 1/125th of a second and be guaranteed that while that shutter is open, you will hit peak brightness. All right? Yes, you will hit zero as well, but it doesn't matter. You'll hit peak brightness, you're fine. You'll hit a peak of that sine wave because that represents our current going up and down 120 times a second. So what happens if you now reduce it to 1/250th of a second? Let's see what happens. Did we catch a peak? Well, we caught one there. Caught one there. Nope, we didn't catch one there. So we're about, two-thirds of the way down. So we've got about 2/3 brightness at that point. So if we took a picture at that moment with 1/250th of a second, we'd only have about 2/3 the amount of light we needed. So we'll let it go. Now that one caught almost the peak. Oh, that one didn't. That gets about half. So if we've lost about half the light, because we're only halfway up to the peak. That one caught the peak. We'll be good there. So now we're going to look at 1/500th, which is how I shot those photos at the beginning of this video. We shot at 1/500th of a second. So let's look. Oh, good Lord. That's hardly any light there. Look how little of the line it caught, and it's mostly on the zero. So there's just a little bit of light there. Okay, almost a peak there. That's good. That's a peak. We'll be fine there. Not so good there. That's next to nothing. That's barely exposed. And so is that one. So you can see when you look back at those other pictures how, some were properly exposed, some were underexposed. You see the color shifts that were going on. And those color shifts were going on because of the decreased voltage in the fluorescent tube, and then it increases again, then it decreases again. So it's going up and down like a yo-yo. The current is going up and down like a yo-yo, and that's causing the gas in the fluorescent tube to vary not only in intensity, but also in color as well. So you saw both color shifts and exposure shifts. Now, these are my studio LEDs. So we're going to see what happens when we use these. And again, 30 pictures, and we're going to 1/500th of a second. So exactly the same conditions. All I've changed is instead of fluorescence, I've got LEDs. And watch what happens. See any change? Nope. You'll see a little jitter at one point because I moved the camera. So there's no change in color temperature. There's no change in anything going on. And the reason why is these LEDs have something called a capacitor. And what that does is it smooths out, those peaks and valleys you were seeing? Well, it smooths them out, so there's no noticeable drop. So when the current changes direction, because they are alternating current devices, when the current changes direction, it changes immediately, so there is no noticeable dip. So as you can see, under the LEDs, no problem. They have a capacitor that just smooths everything out. So here's the thing, and when you are out having to take pictures under artificial lighting, and you're not using a flash, you're just going with, available light, I would suggest you take some test shots at either 1/250th, 1/500th, or 1/1000th to see if you're going to get some flicker. So you're going to get, your exposures are going to go up and down. So maybe 5 or 10 shots in a row, and see if your exposure and your colors are changing. And if that's the case, the fastest shutter speed you can get away with now is 1/125th of a second, or 1/60th even better. That way you're guaranteed to hit at least one peak with 1/25th, 2 peaks with 60th of a second. You get 4 peaks with 30th of a second. So that means you're guaranteed of getting maximum brightness in your picture, and the color will be consistent, which is the other good thing. The issue for us is we cannot assume that all the lights that we're going to work under have capacitors that smooth out the current flow and gives even illumination. So we can't assume that. So either use slower shutter speeds all of the time, which means you don't have to worry, or if you have to work with faster shutter speeds, like for example, you're covering a hockey game in an arena, it's a perfect example, then test it first and see what you've got to work with. Now, the other thing I'll mention is some cameras do have flicker reduction capabilities. So if you are under awkward lighting, turn it on. If the lighting is flickering, turn the flicker reduction on and see if it helps. Well, some cameras like this one have flicker reduction in them, and we would hope that flicker reduction would do some work here to minimize the problems we have with artificial light that flickers. And you can see in this menu choice here, I have the ability to go in and turn it off or pick just the first frame or use all frames. So as you can see, it does come with downsides on continuous shooting, but all frames is likely to be more accurate. Well, what happened when I put flicker reduction on and tried various shutter speeds under my awful old cheap fluorescent lights? This is worst case scenario with my lights, all right? Well, what I found was 60th of a second, as predicted, was bang on, no problem whatsoever. 1/25th of a second was bang on for all but one shot, and that was very, very slightly off for the one shot, and that would be easily corrected in post. It was just slightly dark. And that makes sense when you think that 1/25th of a second is slightly faster than 120 cycles in a second that we have with alternating current. So it's not quite right. So you expect maybe one or two will be a little bit off, and that's exactly what I found. I had one shot that was just a smidge off. Now, as far as 1/250th and 1/500th of a second, what I found was that the flicker reduction, I'm afraid it didn't do a whole lot. It did even out the exposure, but it couldn't deal with the color shift that was occurring. And what we'll do is we'll look at that here. As we cycle through some of these, you'll see the brownish tinge in the image. And that tinge, it would be difficult to remove in post because it's not throughout the entire image. It's in many cases only through half the image. And that's, showing our vertical run shutters, for example. That's what's happening is as you run, the shutter runs through its open and closing sequence, it's seeing the fluorescent light at different stages of the light's cycling, and the flicker reduction can't really cope with it all that well. So not all of the results are usable. So you're going to get a few good results at 1/250th and 1/500th with flicker reduction on, but it's not a great solution, and it's not going to solve all the problems, and it's not going to give you 100% consistent results. So the bottom line is you're still going to have to test, and if you're stuck and you've got to use the fast shutter speed, for example, in a hockey game, and the lights are flickering, turn your flicker reduction on and just hope for the best. And, hopefully the best shot is the one that comes out right, and the not so good shots are the ones with the awkward color casts. So that's the best we can say about this is, know what situation you're under as far as the artificial lights are concerned, whether you've got capacitors in them or not, and then be aware that you can improve matters with your shutter speed, and flicker reduction can help, but it's not ideal. So that's our problem. Those are our solutions. So if you're in that situation, give it a try. Cheers.